I'm going to add a little bit to your existing notes. This was on your homework paper. These are the problems on the back. Just because we got time kind of short on the binomial theorem. So I'm going to show you an expansion. This is not exactly like the problems on there, just like number 4. Number 4 is the third power. I'm going to do this to the fifth power. So first thing I always want to do is line up and make sure that I have everything set up in such a way that I can put in my stuff from Pascal's triangle at the right way. So I'm going to go 5a quantity to the fifth, 3b quantity to the 0, 5a quantity to the fourth, 3b to the first, 5a to the third, 3b to the second, room 5a squared 3b cubed, 5a to the first, 3b to the fourth, and the last power, I should use a longer piece of paper, would be 5a to the 0, 3b to the fifth. Now, before you go write anything else in, make sure your powers add up to 5 here. This is a longer problem. Make sure they add up to 5. And I have all these due. Don't get dizzy here. I'm trying to change my camera. There we go. Okay. Now, on your Pascal's triangle, you can memorize that it's always one more than the power. Or you can say I have 1, 2, 3, 4, 5, 6 terms. I'm going to go to the row that has 6. So my coefficients 1, 5, 10, 10, 5, 1. And then it's just a matter of expanding, and you probably want to do this with a calculator, just being careful to make sure that you don't expand stuff the wrong way. So 5 to the fifth, that's 3,125. And that's a to the fifth, 3b to the 0. So that's just a to the fifth. Plus 5 to the fourth, which I think is 625, times 5 times 3. 9,375 a to the fourth b. And be glad you didn't multiply this out the long way. 5a to the third, which is 125, times 10 times 9. I know 3 squared is 9. So 1,000 or 11,250 a to the third b squared. Working my way through here. 5 squared, so that's 25. So 10 times 25 times 3 to the third, which is 27. 6,750 a squared b to the third. And then I have 5 times 5 times 3 to the fourth. Well, 3 to the fourth is 9 times 9 to 81. So it's 25 times 81. So 2,025 a b to the fourth. And the last term, this is just to the 0, so that's equal to 1. 3 to the fifth, 243. So 243 b to the fifth. So that's expanding the long way. If you look at the same question only to the third power down here at number 4, the only thing that's really different, sorry, my focus on this thing is going crazy. The only thing that's really different is the initial setup. So this is 5a to the third, 3b to the 0. So instead of to the fifth, it's to the third. 5a to the second, 3b to the first, 5a to the first, 3b to the second. You're making sure every time they add up to 3. 5a to the 0, 3b to the third. And then you're finding the rows that they come from. So there are 1, 2, 3, 4 terms. 1, 3, 3, 1. Write them in different color. And then expand, multiply it out. Okay, so the last two are the fourth and fifth. The one thing I will tell you to be careful of is this 1 to the fourth power, and the same with number 3. Remember that when you start expanding 2a to the fourth, it's negative 3b to the 0, 2a to the third, negative 3b to the first. Be careful because on your calculator, negative 3 squared, and we talked about this, you guys don't believe me, your calculator will tell you it's negative 9 because it follows order of operations. So if you're going to use your calculator for a power, make sure you put parentheses around it. The PowerPoint has video links at the end of it for both the long way and the binomial method, and then those links are also on Canvas for you to look at as well.